Alright, I haven't rehearsed this one, so let's see if I can get it on the first try. The ship observes the lighthouse in a direction of 50 degrees west of north. After sailing 36 kilometers in a direction of 35 degrees west of south, the lighthouse is observed in a direction of 50 degrees east of north. Oh yeah, this is going to be bad. Alright, well, let's get a compass rose down first, since they're giving us compass directions. 50 degrees west of north means we have, here's north, and here's 50 degrees west of north. So here's our ship, and it sees a lighthouse. I have no idea how far away it is. There's the lighthouse. Now, this ship goes 36 kilometers at 35 degrees west of south. So there's our 35 degree angle. So the ship goes 35 degrees west of south, and it does that for a distance of 36 kilometers. And now, you know what, I have to extend that line. Not because I've set this up wrong, but because I didn't realize the scale was going to be like this. I'm going to bring in the lighthouse quite a bit closer, and this will make the question make more sense in a minute. Okay, so we'll say the lighthouse was there, and now the ship sails this way. What I'm trying to make happen is, they say once the ship is here, and it's gone, it's 36 kilometers, now it has to look 15 degrees east of north, meaning 15 degrees that way. Change the color. There is our line. This is 15 degrees east of north, and that's the way it has to look to see the lighthouse now. So draw a sketch showing the information given. Here it is. It's a little crazy, but that's all the information. Calculate the distance of the ship from the lighthouse when the second observation is made, meaning the length of this red line. We know this is 36. We don't know this angle, although we might be able to find it.
The zebra hadn't changed his stripes.
What can we find here? Okay. Well, I see one thing we can find. Here, there's 180 degrees on this side of the axis. Here's 50 of those degrees, so we have 130 left. Here's 35 more, which takes us down to 95 degrees left. So this has to be a 95 degree angle. That's something. What else have we got? This angle, I know that 15, which is nice, but I don't think... What can we do with that? I have a scary, desperate idea, but I'm trying to think of something nicer than that. I actually don't think we have a choice. Alright, brace yourself. I'll try to make this make sense. First, we have this 35 degree angle here. Imagine we extend a line down like this and make a right triangle. This green right triangle. It's got a 90 down there, 35 here. So what's this angle? 90 minus 35. This would have to be 55 degrees in the corner. Alright. So now, what's this angle in black? There's 90 degrees in this corner. We've used up 55 of them here, which means we have 35 degrees left. There's another 15 degrees in this little red sliver, so there must be 20 degrees in this corner. You tired yet? I am, but we are getting there. We're winning because we're filling in information. That's 20. That's 95. Total of 115 degrees. That means this must be 65. And now we know all three angles in this triangle. Great. And now I believe we can solve this thing because we have an opposite pair, finally. We have this 36-kilometer side, and we have the angle across from it. And then we want to find this side, which I'm just going to call X. And we have the angle across from it, the 95. We're in business. It's going to look like, let's see here, X over sine 95 equals 36 over sine 65. So X, you cross multiply, you do 36 times sine 95 divided by sine 65. And when the dust settles, you find that X is 39.6 kilometers. Whew. Now, there are almost certainly several ways to solve this problem. You may think of a way that is much simpler than what I just did, and then I'll look very stupid. But if you do, that's great. I'm happy for you. Just my point is, for a lot of this, I didn't know where I was going, and I didn't know how these angles were going to help. But if you have a diagram and you're able to fill in any new information, you're building up your supply of knowledge, and almost always you can keep doing that until finally you crack the problem. So if you don't know where you're going, don't stop. Try something, figure something out, and then take a new look at the problem and keep going like that. That's how you suddenly realize that, hey, wait, I've got opposite pairs, sine law can help me out of this.